Okay, answer me this. If you walked outside and saw a 355-foot ship pointing straight down into the ocean, what's your first thought? Mine would probably be, well, somebody had a really bad day. Except with Flip, that meant everything was working perfectly, because this thing wasn't sinking. It was designed to stand vertically in the ocean on purpose, and somehow that's not even the strangest part. Flip stood for Floating Instrument Platform, and it was originally developed in the 1960s by researchers associated with the Marine Physical Laboratory at Scripps Institution of Oceanography. From a distance, it looked like a bizarre ship. But technically, Flip wasn't really a conventional ship at all. It didn't even have its own propulsion system. It had to be towed horizontally out to wherever researchers wanted to conduct an experiment. And that's where the fun started. Once Flip reached the research area, the crew would begin flooding massive ballast tanks located toward one end of the platform. As seawater entered, that end became heavier, and slowly, very slowly, the entire 355-foot structure began rotating. 5 degrees, 20, 45. Keep going, until Flip had rotated roughly 90 degrees. At that point, only about 55 feet remained above the water. The other 300 feet were pointing almost straight down beneath the ocean surface. Think about how ridiculous that would look if you didn't know what was happening. 1 minute you're standing on something that looks like a ship, then the floor starts becoming a wall. And eventually, what used to be a wall becomes your new floor, which creates a pretty obvious problem. How do you build the inside of a vessel that's supposed to operate in two completely different orientations? The answer is exactly as weird as you'd hope. Some of Flip's interior spaces were designed with that rotation in mind. Certain doors, fixtures, and surfaces had to work differently depending on whether the platform was horizontal or vertical. There were even specially designed features so crew members could use the living and working areas after the entire platform rotated. A normal ship designer spends years trying to make sure the ship doesn't tip over. Flip's designers basically said, "We're going to need it to tip over every time." But here's the question that matters. Why? Why go through all of that trouble just to make a research platform stand upright? Because the ocean never stops moving. A normal ship sitting on the surface gets pushed around by waves. It rolls, it pitches, it rises and falls. That's fine if you're transporting cargo. It's a nightmare if you're trying to make extremely sensitive scientific measurements. Flip solved that problem using its ridiculous shape. Once vertical, most of its structure extended hundreds of feet below the surface. Down there, the ocean isn't being thrown around by surface waves nearly as much. That enormous submerged section gave Flip incredible stability. Surface waves could pass around it while the platform remained relatively steady. And suddenly, scientists had something incredibly valuable: a stable place in the middle of the ocean to conduct experiments. Researchers used Flip to study things like underwater acoustics, wave behavior, ocean circulation, marine mammals, and interactions between the atmosphere and the sea. Because it was so quiet and stable, Flip became especially useful for acoustic research. And remember, it didn't have its own engines. That wasn't necessarily a weakness. Engines create noise. Propellers create vibration. Mechanical systems can interfere with extremely sensitive underwater measurements. Flip could sit out there without a propulsion system, constantly rumbling underneath the scientists' feet. Now here's another part I love. When the research was finished, they had to put the thing back down. Compressed air was pumped into the flooded ballast tanks, forcing seawater back out. As the tanks became buoyant again, Flip slowly rotated back toward horizontal. Then it could be towed to its next destination. So this machine spent decades intentionally performing a maneuver that would be an emergency on practically every other vessel ever built. And it did it over and over. Flip entered service in 1962 and remained a scientific research platform for more than half a century. Eventually, maintaining the aging structure became increasingly difficult and expensive. In 2023, after roughly 60 years of service, Flip was retired. And honestly, that's almost disappointing, because modern engineering has given us autonomous ships, underwater robots, satellite ocean mapping, and incredibly sophisticated sensors. Yet Flip still feels futuristic, not because it used some impossible technology, but because the idea was so beautifully strange. Engineers had a problem. How do we make precise measurements from a platform sitting in a constantly moving ocean? They didn't try to build a normal ship with better stabilizers. They completely changed the geometry, put most of the structure underwater, used the deep ocean for stability, and redesigned the entire platform around that one idea. That's engineering at its best. Sometimes the solution isn't another computer, another motor, another complicated piece of software. Sometimes somebody just looks at a 355-foot ship and says, What happens if we stand it up? And somehow, that crazy idea works for 60 years.